squared. Can you take the square root of 16? Does it work out perfectly?
Yeah.
So the square root of h squared is h, and the square root of 16 is 4.
Mhm.
Now, if you merge those together, 4h, and then you double it, you get 8h, which is what you have in this position right here.
Mhm.
Okay. Now you might say, well, isn't there a negative there? And I'd be like, yeah, there is a negative there. What that means is the answer here ends up having a negative in the middle.
Okay.
Okay. So I know there's a lot like there's a lot going on here. Let me draw the formula for difference of squares. It's a squared minus 2ab plus b squared. That's what you have in your problem. You have
Mhm.
this. Your a is h, your b is 4.
Mhm.
And this always becomes a minus b squared. It's really similar to the last one, but not the same. Your a is h though, your b is 4. So it ends up being h minus 4 squared like that.
Okay.
All right, so I really feel like we should do another one before we
Mhm.
move on to the other type. So let me give you another one here to think about. X squared minus 6x plus 9. So this is in this form, a squared minus 2ab plus b squared. Your goal is to figure out a and b, just like the difference of squares.
Okay.
Can you tell me what this becomes?
Would A be X and B be 3?
Yes. Now,
Okay.
because there's a minus here, it becomes a minus b squared in parentheses.
Okay.
So tell me what it becomes here on the left.
X minus 3 squared.
Good. Fantastic. Now the other perfect square trinomial form is really, really similar. It's a squared plus 2ab plus b squared, and this is the one that becomes a plus b squared. So the only difference is that sign in between them.
Okay.
Any questions on that?
No.
All right, so let's go to number 4. This is also a perfect square trinomial, and it really does help that I'm telling you that, but I mean, that's it. The identification is key here. This
Mhm.
is an a squared plus 2ab plus b squared. So you're trying to figure out what squared gets you back to 9k squared, and what squared gets you back to 225.
Mhm.
So if you can give me either of those, let me know.
Would it be 3K
Good.
and 5K?
Just 5, because you
Oh
already
yeah,
just going.
5. Yeah.
So your a in your problem is 3k. Your b is 5, and it's okay to write that.
Mm-hmm.
In fact, I mean, I would almost want you to write that. I mean, that would be
Okay.
good intermediate step. So this becomes a plus b squared. Your a is 3k, your b is 5, and you square it like that.
So to determine the signs, like the last one was a minus and this one was a plus. So how would you like tell?
It's
Is it like the
based on what's in front of the middle one.
Okay.
See how this middle one, this one here.
Mm-hmm. Okay.
Good question. All right, let me have you do one more here. Quick search for one. That's
Wait, so I have a question. So
yep.
the 30K in the middle, does that have anything to do with, so like I know we're figuring out what the perfect square is for the 9K and the 25? Is there anything to do with the 30K or no?
Well, it's kind of a check. I mean, I don't think you're gonna get any exceptions, but is 2AB equal to 30K? Is 2 times 3K times 5, does that equal 30K?
Mhm.
And it does. 2 times 3 is 6, 6 times 5 is 30. Now, are there exceptions? Of course. I'm not seeing them like in this sheet that you're doing, but
Mhm.
they're they very well could be there.
Okay.
Okay, so sorry, I'm just trying to find one here that's not, crazy.
Mhm.
Let me give, here's one that I found here. 25 W squared minus, I'm sorry, plus 40W plus 16. This again, it's another perfect square trinomial.
Mhm.
Go ahead and see if you can work that out.
I got 5W squared plus 4.
So because you're going back to a W squared, it can't be squared inside here because a squared squared would be a fourth.
Oh yeah, so it'd just be 5W because that get it to 5 to 25W squared.
Good. What about the other one here?
Um, 4.
Okay, so what does it reduce to? What goes inside parentheses here?
5W plus 4
Squared. Good.
squared.
Okay, so we can move now to solving,
Mhm.
and really the better instructions for 6, 7, 8, and 9 is to solve by factoring.
Mhm.
Okay, it really should say solve by factoring. And that's what you want to think when you go to your test or quiz here. You want to say, okay, I'm going to have to factor. And you have to identify what kind of factoring this is.
Mhm.
Can you tell me what type of factoring this is?
No.
It's like number 1. So here's what you don't have to know that it's difference of squares. You do have to
Mhm.
know how to actually simplify difference of squares.
Okay.
So this is something squared minus something squared. You got to figure out the A and the B value.
Okay. So the first one would be W,
Good.
and then okay, I don't have a calculator with me right now.
13.
13. Okay.
So you got to write your two binomial pairs. Do you remember that?
Be W square or just W minus 13,
Okay,
and then W plus 13.
very good. Now, if we were factoring, we'd be done, but we're not done because we're solving.
Mhm.
Solving means to set each term equal to 0. So in this problem here, each term has a W in it, or each term has a variable in it. So you're setting the W minus 13 without the parentheses equal to 0, W plus 13 equal to 0, and solving for W.
Okay.
So W equals 13 and W equals minus 13.
On these, wouldn't you just select the W minus 13 equals 0? You just add 13 to both sides. And
That's right.
then on the other side, you'd subtract 13 both sides.
That's correct. Yeah.
Okay.
Let me know when you get all that down.
Yep.
All right, so let me have you try one on your own here. Let's say it's y squared minus 25 equals 0. Okay, this is just another difference of squares problem. Go ahead and
Mhm.
set this one up and see what you come up with here for your two answers.
I got y equals 5 and y equals -5.
Yes. And there have to be two answers.
Mm-hmm.
Okay, these are all quadratics. They all have two answers. There's never a situation where there's only one.
Okay.
Okay. All right, so let's look at number 7. New type of problem here. All right, so the very first type of factoring that they should have mentioned in class is what's called a greatest common factor. Like
Yeah.
you always look for a greatest common factor, and it could be a number, it could be a variable, it could be
Mm-hmm.
both.
Mm-hmm.
This one is a both. There's both a number and a letter that goes into both of these terms. Can you tell
Yeah.
me what either of those are?
2 and y.
2 and y. So that goes on the outside here. On the inside, you're dividing both by 2y. Okay, so can you tell me what goes inside parentheses?
It'd be y squared
Minus?
minus
No, so you don't have a calculator. You're normally allowed to use a calculator in the class?
yeah.
Okay.
Yeah. Would it be
Got it.
60 or no?
64.
Yeah.
Okay. Now this is where a lot of students are like, well, how do I know when I'm done? And the problem is you don't know until you've done a bunch of these, but you keep trying to factor. Like you should see this thing on the inside here and say, okay, that looks like something. What does that look like to you on the inside?
Difference of squares.
Difference of squares. Yeah. So you've got to figure out what that factors to here.
Mm-hmm.
Okay. So let me know what you come up with for that, please.
So it would be y minus 8
Okay.
and then y plus 8.
Yes. Very good. Okay. Now this is very important. You set each term. So terms have a variable in it equal to 0.
Mm-hmm.
So in this problem, you're going to set 2y equal to 0, y minus 8 equal to 0, and y plus 8 equal to 0.
Okay.
And you have to solve all three of those.
Okay.
All three. So you're going to have 3 answers when you're done here. So go ahead and work that out. Let me know what you come up with.
Mm-hmm. I got y equals -2 and then y equals 8 and y equals -8.
Okay, so agree with your second 2 answers. The 2 is multiplying the y. So to undo that, you're dividing by 2.
Oh,
It's a small thing, but you may not get
okay.
partial credit if you don't write it out perfectly.
Okay.
All right, any questions on that before we move on to another one?
No.
All right. All right, so let's see here. We actually should do the next one. We should do 9 next.
Okay.
All right, so if you look at 6, 7, and 8, I know we said, hey, let's look at 9. But if you look at 6, 7, and 8, they are all set equal to 0.
Mm-hmm.
Okay, this one's not. It's set equal to -1. You might think, well, that looks different. It is different, but you want to get it equal to 1. So you're going to add 1 to both sides. 169m squared minus 26m plus 1 equals 0.
Okay.
All right. I'm going to tell you, and the challenge will be for you, but your key to doing all this test is to identify that this is a perfect square trinomial.
Mm-hmm.
This is what's hard. It's like, well, how would I even recognize that? So you have to recognize that the first one is something squared. The last one is something squared. 2ab there in the middle.
Okay.
Now you said you didn't have a calculator, so it makes this a little tough, but your a in this case is 13m.
hmm
What is your b? What squared gets you back to 1?
What squared gets you back to 1? Just 1.
Just 1. Good. So you've kind of answered it, but is 2 times 13m, which is a, and times 1b, is that 26m?
No.
What is 2 times 13 then?
Oh wait, no, yeah, it is.
It is, yeah, and that's what
Yeah.
you want. Like that's what you want. Like if this doesn't work, then it is not a perfect square trinomial. That's not negative, but that's okay. That just
Mhm.
means you've got to put the negative between them there. So your answer is 13m minus 1 squared, like that. So this first line goes to this last line like that.
Okay. Okay.
All right. Any questions on that?
No.
Okay. No, we're not done. We have to solve this for m.
hmm
All right. Now you're used to setting them equal to 0. You can do that here as well. You just have to write both terms. Like there's actually, the squared means they're just the same.
hmm
So you set them each equal to 0 like this.
Okay.
But you find that they're the same.
hmm
But there are 2 solutions. It's just that they're the same in this case.
Yeah.
Any questions on that?
No, I think I got it.
Okay. Let me quickly look at the next page to see if there's any more like that one. Not really. So actually, and there's always kind of a good order to do these in. Actually, we should do 15 next.
Okay.
I guess. Sorry, let me just look at these. Okay, yeah, let's do 15 next.
Okay.
All right, so just like in the previous problem, you want it to equal 0. So you're going to
hmm
subtract 49 from both sides. So it's 16 x squared minus 49 equals 0. Whenever you see 2 terms, it's almost always difference of squares.
Okay.
Okay, so you have to figure out what squared minus what squared gets you back to the previous line.
hmm
Can you tell me what that is?
It'd be 4x
Okay, and then for this
negative
49.
7. Negative
So
7.
it's always positive inside here.
Oh, okay.
Okay, so this is difference of squares. I'll write the formula off to the side here. A squared minus b squared is a minus b, a plus b. Can you tell me what this becomes when you?
Yeah, it'd be 4x minus 7 and then 4x plus 7.
Very good. All right, so
Then
now
we,
you set them each equal to 0, and go ahead and give me the answers after you solve this, please.
I got 4x equals 0 for both.
But you're going to add 7 to both sides first, right? Or add
Oh,
7, and so that's 4x equals 7.
oh, okay.
Then subtract 7 from both sides.
Oh, yeah. Okay.
Divide by 4. Divide by 4.
Okay. Yeah.
All right, any questions on that?
No.
Okay. All right, so here is, we'll look at 11 next. Try not to try to do some of those same ones we've been doing to get some more familiarity with it. So this has two terms on the left. It's got that x squared and that 18x. So you might think, hey, Matthew said two terms, it's difference of squares. Is there a subtraction though between them?
No.
So this is not difference of squares. What's the very first type of factoring you should always try?
Greatest common factor.
Greatest common factor. Very good. Does this have a GCF? Is there a GCF between x squared and 18x?
Yeah, the x.
The x. So it's x. Tell me what goes inside parentheses, please.
X plus 18.
Okay. Now you set each x term equal to 0. So you set x equal to 0 and x plus 18 equal to 0. Okay. Will you solve this for me? What's the answer to the second one here? If you're speaking, I am not hearing you. So the first one's already solved for x, right? Okay, looks like you're back. I was asking you to solve these. Do you have an answer for me for the second one?
Yeah, so minus 18 to both sides. X equals negative 18.
You got it. Very good. Okay. All right. Next one we'll look at is 14. There's a reason to we're doing them this way. Try to summarize that here at the end or after we do this problem. So just like a bunch of the other problems we've been doing, you've got to get 0 on the right-hand side. So in this case, you're going to add 4 to both sides. 9x squared plus 48x plus 64 equals 0. There is no GCF. There is no GCF. So your next option is difference of squares. This is not a difference of squares. There's no subtraction and there's not two terms. The next one is perfect square trinomial. So for that one, you're hoping for something squared and something squared in the first position and the last position. Do you see anything there that looks like it might work? Yeah. What would go in the first position there?
3x.
Okay.
And then 8.
Very good. Now, this is your A, this is your B, and is 2AB, does that equal 48x?
Yes.
2 times 3x times 8, yeah, that equals 48x. You're in good shape here. What goes in parentheses down here?
It'd be 3x minus 8, 3x plus 8.
That's true if it's difference of squares. This is perfect square trinomial, so it's 3x plus 8.
Oh, okay.
Now I'm gonna try and summarize this here, but yeah, this is the typical, it's very typical to kind of mix these up because there's so many, they're all kind of look the same. All right, so I'm just separating it, right? 3x plus 8 squared means 3x plus 8 times 3x plus 8. You set them both equal to 0.
Mhm.
And you solve for x. So go ahead and give me your final answer.
I got x equal negative 8/3 and x equals 8/3.
They're both the same though. They're exactly the same. 3x plus 8, 3x plus 8. So the answer can't be different. It's got to be the same. So
Okay.
it's actually what's called a double
Okay.
root. Just means that it's repeated twice. Okay, so we should try to quickly summarize just the first couple of types that we're doing. So the first type of factoring you always try is GCF, greatest common factor. Okay, there's not really any formulas associated with that, but there are for the next two. So difference of squares. So this is a squared minus b squared, and it becomes a minus b, a plus b. The third type is a perfect square trinomial. And this has two forms. It has a squared plus 2ab plus b squared, which becomes a plus b squared. So when you see them like this, you can tell that they're very different. Difference of squares has two terms. It becomes a minus and a plus. Perfect square trinomial has three terms, and it becomes just an a plus a b. It also has this other form here, where instead of a plus, it's a minus, and that changes what goes inside parentheses. It becomes a minus b squared like that. So the problems we've done tonight have all fallen under these three possibilities, but there are more, and that's where the challenge is. So we have a choice. We can do more of these, or move on to new stuff, which could be more confusing, might be okay. I'm not sure, but that's kind of where we're at here. What would you like to do? More of these or move on to the other types of factoring?
I couldn't hear what you said. It kicked me out. It's like really windy at my house.
Okay. So I'm asking if you want us to do more of these or some like the new ones. Like there's other types that you'll see on your test, but I would say there's still confusion on these, but we can move on to new ones if you want.
Probably the new ones.
Okay, let's do that. So the next type of factoring is what I call a equals 1. And we'll look at some of those now. I think you've only got one though, so go fairly quickly here. All right, actually got two. Let's go to number 13.
Okay.
Snip that in here. All right, so a equals 1 refers to what's in front of the first letter there. There's really a 1 in front of the p squared, which is not written. When it's in this form, you look at the last number here, minus 60. And you're looking for two numbers that multiply to minus 60, but then add up to positive 7. So you have to write all the possible combinations or be a really good guesser to come up with them. I think it's worthwhile to write them all down, especially if you're into sort of patterns and things like that, because you might see it. -4 and 15, or a -15. Notice one is positive and one is negative each time, because that's the only way to get back to a negative. But you keep going until you get, the one that you want, -5 and 12, 5, and negative 12. We can stop here because this one works. Okay, so the hardest part about doing this type of problem is working this list until you get the 2. Like you can spend an inordinate amount of time trying to figure this out. You know, and it's bad. You gotta be fast. So if you have a calculator, what you will do is do 60 divided by 1, 60 divided by 2, and so on. And you write down the numbers that work out perfectly. Okay. And you stop when you have ones that work. Okay. So this becomes P minus 5 because of that minus 5 there. P plus 12 equals 0. What do you do from here? What have we been talking about all night? What's the next step here for this?
Is it the difference of squares?
Nope. We're done. We're done with difference of squares. Like we're down to 2 binomials that equal 0. How do you solve them? How do you get the value for each of them? What do you do to each of these? Set them equal to 0. Yeah.
Set them both.
Yes. Sorry if it's repetitive because I know you said there's a lot of wind and all that. Just you know, do the best you can here. So go ahead and solve these, please, and give me your final answer.
Okay. I got P equals 5 and P equals negative 12.
Very good. Okay, so this type of problem, this A equals 1, it's the fourth type of factoring. You look at that last number, you got to build a list, and you really hope that one pair adds up to that middle one, and only one should work like that. So we'll do another one here. Number 12 is very much like that one, so we'll do 12 next. All right, so we're going to subtract 3m from both sides. M squared minus 3m minus 54 equals 0. So notice when you subtract, like you can't combine it with anything, you get the 3 terms. There's a 1 in front of the m, that's the a equals 1. So just like in the last problem, you look at that minus 54, and you got to find all the possible numbers that multiply to minus 54. You're looking for the one that adds to minus 3. Okay. Now, most students don't build the list, and that's fine. Okay, no big deal. But how comfortable are you building, like getting this right, this number here? What's your strategy going to be tomorrow to do that?
Usually, like when we do these types of problems on tests, I build a list.
Oh, good. You're the exception. That's great. That's awesome. One of the things that might help you is they've got to be like 3 apart. Which means that like you don't need to start at -1 and 54. As much as I like that, and I do that, you can start further down the list. Okay, like you're eventually going to get to 6 and -9, or -6 and 9. Which one of those works for this one? Which one adds to -3?
The 6 and -9.
Good. So you write m plus 6 because 6 is positive, and then it's m minus 9. And then you set each of those equal to 0. Okay. So go ahead and solve this and give me your final answers, please.
M equals -6 and M equals 9.
Yes. Very good. All right, let me see if that's the last of those A equal 1 types. Notice that they have 3 terms in them. So they take on this form. I'll write that out. X squared plus bx plus c could be minus bx plus c or minus bx minus c plus bx minus c. But the point is for this a equals 1, there's a 1 in front. There's always a 1 there. That's what you're looking for. But like,
Mhm.
if you're looking at your paper,
Yes.
11 is not this form, even though it looks like it might be, because it's got 2 terms. GCF is, or a equals 1 requires you to have
Yeah.
3 terms.
Yeah.
All right. Unfortunately, we got to do the most awful type, which is a 5th one here, which is grouping.
Mm.
So the 5th type here, we'll have some time here for, looks like a couple of examples here. The 5th type is a not equal to 1, and it's called grouping. You end up using grouping. You might have even heard like the diamond method in class. So notice this time that the leading term 3, well, it's obviously not 1.
Mhm.
And it's like, well, what do you even do here? So that this time you take the 3 times the negative 10,
Okay.
which is negative 30. And now it's kind of like what we were doing in the last problem. You're looking for 2 numbers that multiply to minus 30, but add now to minus 13. Again, it's easy to get these wrong. It ends up being 2 and negative 15. It's not 10 and 3, because one has to be negative, one has to be positive. All right, now what we're doing is we're splitting apart. We're actually splitting this apart.
Mhm.
And you have a choice here. You can either write it as minus 15a plus 2a or 2a minus 15a. Now, when I bring down the other 2 terms, you might wonder, well, how do you even decide between these? Like, how do I know which one is right? You look at that first number and you're like, which pairs better with 15a? Because what you end up doing here is grouping. You're going to find a GCF between these first 2. So what
Yeah.
most students would, you kind of look and say, okay, well, I think that one groups better with it.
Yeah.
So you use that
Mhm.
one.
Yeah.
Just rewrite it here. You can do it the other way, but you'll find that just take a moment to see which one is better. What is the GCF between 3a squared and 15 minus 15a?
3A.
So there's a 3a there, becomes a minus 5. A minus 5. What goes in between them?
And 2.
2. Good. Plus 2. And so you end up writing a minus 5. It's actually double factoring 3a plus 2. Now I've made the mistake here of not setting all of this equal to 0 the whole way down. But now you set each of them equal to 0.
Okay.
A equals 5. I'm sorry, let me actually write that out correctly. A minus 5 equals 0. 3a plus 2 equals 0. So a equals 5. Will you solve the one on the right for me, please?
I got A equals negative.
Good. Very good. Got it. All right, so we'll try to quickly do 17 here. It's of the same
Mhm.
flavor,
Yeah.
if you will. These are the absolute worst, longest. There's no shortcuts here.
Mhm.
This is another a not equal to 1 because that 12 is not 1. There is no GCF. So unfortunately, you have to take this 12 and multiply it by minus 35, which you get a large number there.
Mhm.
Why am I struggling here? 10 times that's 350. 410. 410. let me just double check.
Mhm.
It's 420. Lovely. All right. So your goal here is to find something that adds up to 1. That means they're 1 apart.
Mhm.
Okay. So you might think, well, like, how do I even figure that? Well, choose numbers that are closer together. And just because we don't have a ton of time here, I'll give you the answers here. It's -20 and +21.
Mhm.
Okay. But like, kind of start in the middle, like don't start at 1.
Yeah.
It might take you a while. So the question now is, well, should you put the minus, should it be -20x plus 21x, or should it be 21x minus 20x? You're deciding which pair is better with the 12. And there's not a wrong
Mhm.
answer. What do you see? What stands out to you?
The 21x.
Okay. All right. So now between 12x and 12x squared and 21x, you're looking for the GCF. It ends up being 3x. So
Right.
4x plus 7. And then you immediately write that over here on the right, and you got to figure out what goes in between them.
Yeah.
Ends up being -5.
Mhm.
So now you factor again, 4x plus 7, 3x minus 5 equals 0. And you set these both equal to 0.
Mhm.
All right, so go ahead and solve those and let me know what you come up with for that.
I got x equals 5/3 and x equals -7/4.
Very good. All right, so in the just the limited time we've got left here, I'm going to give you the steps to solving 8. I think we did not get to 8. All right, so 8 is a GCF followed by a not equal to 1 grouping type problem. So you maybe have some time to do that or find an online thing to help. We did
Okay.
not do 10, I don't believe.
Mhm.
10 is kind of an odd difference of squares. I'll just show this briefly. It's f minus 7 squared minus 225 squared equal 225 equals 0. So it ends up being f minus 7 squared minus 15 squared. And you can use difference of squares for this one. But we are unfortunately out of time here. So maybe get some help in that before class tomorrow.